chemical weathering, warm, moist conditions. Tropical rainforest, great place for chemical weathering. But again, remember, we need both for this to occur. So climate is the most significant factor, and then rock type is a secondary factor in determining rates of weather. Remember, your quartzite and Rib Hill, very, very slow process of weathering. Okay, weathering produces sediments. And again, one last time, the sediment, yes ma'am? Rock type. Okay, weathering, what's a sediment again? What's a sediment? Okay, broken regolith, broken bedrock, or sediments. Now, basically, we're looking at clays, silts, sand, and gravel. Which are the smallest sediments? Clays are the smallest sediments. Okay, that's weather. What's erosion? What's erosion? Weathering is a breakdown of rock units. What's erosion? What? Okay. Erosion is the movement or displacement of sediment. And it's done via generally three methods. Anybody? How are sediments displaced? Wind, someone said. What? Glaciers. Water. And the most significant one, constantly at work at all times, gravity. By far the most significant conveyor of sediment is gravity. It's constantly at work. It's on all surfaces that show any inclination. The only place that doesn't affect sediment is an absolutely flat surface, and there are very few absolutely flat surfaces on the face of the earth. So gravity moves more material than the others because it's constantly at work, constantly moving. The process of gravity moving materials is called mass wasting. It's not what you do on a Saturday night, but mass wasting is the movement of materials by gravity, only by gravity. Typically, we can identify the various types of mass wasting activities by just simply putting them into two categories. Slow mass wasting is such that you see the end results but not the movement. Rapid mass wasting is any time you see any movement, whether it be feet per day or miles per hour. So slow, you see the end product, you don't see the activity, and rapid, you see the motion actually taking place. Before we go any further with this, what I'd like to do is just give a couple of examples of rather unique mass wasting types. with a fair amount of D&D. Where are the Andes Mountains? South America. Okay, they're on the western edge of South America. They're mountains that receive a lot of snow, a lot of rain. They're in a earthquake zone, so there's a lot of tremors and vibrations that occur in the Andes Mountains. The Andes are high mountains. They're 50% higher than our Rockies. They're 20 to 22,000 feet above sea level. So we find these mountains just reaching up the coastline to elevations of 4 miles or so above sea level. Tremendous accumulation of ice and snow near the summit. And the accumulation of ice and snow is rather precarious. Periodically, chunks of this will fall off, and moving snow is referred to as a avalanche. Now, there are a couple of types of avalanches. There's snow avalanches, rock avalanches, and debris avalanches. But in this case, it would be a snow avalanche. Well, in 1969, a group of hikers went up this mountain, and when they got near the top, they realized that this snow cover was extremely precarious. They thought that literally a chunk of ice more than 10-story building high had the potential of coming off of this mountain. They realized that it might be a problem for folks down the mountain valley. So as good hikers, they came back down the mountain and they went to the local authorities. And they said, local authorities, you've got a problem in the neighborhood. You've got this mountain with the massive ice at it, precariously balanced up there. If it falls, you may have a disaster. Now, if you're a typical local authority, what are you going to do about it? Now, you do something, because if you do nothing, you're responsible. So what do you do? What do you do if someone tells you something's going to happen and you're just a local authority? You pass the buck. You send it up the line. The local guy gives it to a regional guy. The regional guy gives it to a guy above him, and it eventually ends up in the capital. And you're so far removed, you don't care. This little mountain village with these people and the snow. I've got bigger problems. I've got a mistress in the closet that the news media is going to find out about, so I've got to try and hide that. I don't have time to deal with the snow. But you've removed yourself from the responsibility locally. You pass it up, someone else is going to take care of it. Well, nobody took care of it. And all of a sudden this thing decides it's going to break loose. And it drops vertically 12,000 feet. So this, by definition, would be classified as a fall because it's not attached to anything, it just drops. And it moves across the landscape here, roughly 9 miles. So it drops 2, moves horizontally 9 miles in roughly 4 minutes. It's exceeding 240 miles an hour. Now, when the big chunk of ice falls, it begins moving down the mountain slope as a solid block of ice. And again, they described it as being a 10-story building high, several blocks in dimension. Well, as that thing moves down the mountainside, it's going to displace a phenomenal amount of air. And you have the shock waves radiating away from this cascading sheet of ice. Rocks are being thrown about, trees are being thrown about, animals are being thrown about, people are being thrown about by the shock wave. Now, for it to reach the speeds that they've suggested, this